Hello everyone. Today we are going to discuss data warehousing and its uses. Welcome to this presentation on Introduction to Data Warehousing, a foundation for business intelligence. I'm excited to walk you through the key concepts, architecture, and applications of data warehousing. Here's what we'll cover today. What is data warehousing? Its key characteristics, major components and architecture, the ETL process, OLTP versus OLAP, data marts, benefits and challenges, real-world applications, future trends, and finally, a summary and Q&A session. A data warehouse is a system designed for reporting and data analysis. It acts as a centralized repository, integrating data from various sources. The main purpose is to support business decisions using historical and consolidated data. Data warehousing emerged in the late 1980s, pioneered by Bill Inman. Over time, it evolved with advancements in computing, storage, and database technologies, shaping the modern tools and platforms we use today. Bill Inman, known as the father of data warehousing, defines a data warehouse as a subject-oriented, integrated, time-variant, and non-volatile collection of data in support of management's decision-making process. Let's unpack this in the next few slides. A data warehouse has four main characteristics: subject-oriented, integrated, time-variant, non-volatile. Each of these ensures that data is useful for business analysis and strategic decision-making. This means the data is organized around major subjects, such as sales or customers, instead of daily operations. This subject orientation enables focused and relevant data analysis for each business area. Integration ensures data from different sources follows a consistent format. Whether the data comes from spreadsheets, relational databases, or APIs, it is standardized and clean to maintain accuracy. A data warehouse stores historical data, allowing organizations to track changes and trends over time. Every record is timestamped to facilitate time-based analysis. Once data enters the warehouse, it isn't frequently updated or deleted. This non-volatility ensures data remains stable, making it reliable for long-term analysis. The main components include data sources, ETL tools to process and clean data, data storage for structured organization, metadata for data about data, query tools for retrieving and analyzing data. Data warehouse architectures typically follow three models: single-tier, less common; two-tier, moderate separation; three-tier, most common, with clear separation of concerns. In the three-tier model, the bottom tier handles data extraction and transformation. The middle tier stores data in the warehouse. The top tier is where users access data via tools like dashboards and BI reports. The ETL process stands for extract, collect data from various sources; transform, clean, validate, and reformat it; load, insert it into the warehouse for analysis. OLTP systems are designed for day-to-day operations, with current data and simple queries. OLAP systems, on the other hand, are built for complex, analytical queries using historical data. For example, OLTP might record a sale, while OLAP analyzes sales trends over a year. A data mart is a smaller, more focused version of a data warehouse, tailored to a specific business line like marketing or finance. Types include dependent, sourced from a central warehouse; independent, created directly from source systems; hybrid, combines both approaches. Benefits include better decision-making with historical insights, consistent and clean data, enhanced business intelligence capabilities, faster query performance due to structured design. Despite its advantages, there are challenges such as high initial setup costs, complex data integration processes, ensuring data security, regular maintenance and updates. Data warehouses are used across many industries: in retail, to analyze customer behavior; in finance, for risk and fraud detection; in healthcare, for managing patient histories; in telecom, for analyzing call data and user patterns. Looking ahead, data warehousing is evolving to include cloud-based solutions for scalability and flexibility, real-time warehousing for instant analytics, integration with data lakes for unstructured data, use of AI or ML to automate insights and predictions. To summarize, we discussed the fundamentals and characteristics of data warehousing, its components and architecture, the ETL process and comparison with OLTP, benefits, challenges, and real-world applications. Ultimately, data warehousing is a cornerstone of business intelligence systems.